So today we're going to look at Hive. Okay, we'll also look into some details on Hive query language. So this is what we're going to cover today. What is Hive? Where do we use Hive? Why go for Hive when Pig is there? And we'll look at the Hive architecture. We'll look at the different components of Hive. How Facebook uses Hive. I mean, I'll also show you some. I've actually requested the Edureka team to give me access to their Facebook page, the admin page, and I'll show you how and where Hive is used in, say, that. Okay, and then we look at what are the limitations. We look at some of the different data types in Hive. We'll look at a few demos there. I'll show you how to say create a table in Hive, how to create a database. Okay, and then we'll look at the different things like partitioning, bucketing in Hive. We'll also look at the differences between managed tables and external tables. We'll look at some how to load data in Hive, and we'll also look at our favorite healthcare use case and see how do we apply Hive there. Okay, we'll also look at some of the examples of how to create a join using Hive. Okay, so these are the topics which you're going to cover today, and so let's get started then. So what is Hive? I'll just quickly read through these points, and if there is anything which you are not clear of, I can answer that. So data warehousing package built on top of Hadoop, used for data analysis, targeted towards users comfortable using with SQL. See, a lot of tools are based on the usability, ease of use. So Hive has one very big advantage where it is very similar to SQL. Okay, that's why it is widely used. Okay, so adaptability also is, see, I'm sure you can write the most difficult tool, most complex tool. If you do not look at the usability of that, then you will not be able to make that tool adaptable, right? Hive can extract data from HDFS, yes. That's right. Parmesh, just give me some time. We'll come to that. Okay, we'll just come to that as well. Okay, how does the Hive extract data from HDFS? Okay. Now it is similar to one thing which I was talking about was I mean, and that comes from, say, a product development kind of experience. I'm sure a lot of you guys understand that well. For the people who have I mean, that's a big piece of advice here to all the people who are trying to build products, who are trying to build companies as well. You should, before building the product, you should always look at the usability. Who is going to use it? How is going to use it? Is it easy to use? Okay. Now a lot of people build products, they don't know how to market it. But the more important thing than marketing probably comes second. Adaptability of a product or a usability of a product is the most important thing, and then you should have a marketing plan for that. And the third thing is how to build that product. Okay, so who is the customer? How is he going to use it? What are the problems you're going to solve? And will it be easy to use, or will it be easy for a customer to actually move from a particular his way of doing things to the new way of doing things which you are actually trying to say? I mean, the Hive is quite a disruptive product in terms of the capabilities, but it is not really disruptive in the sense that you don't have to learn a lot of new things. That's why it's so popular. Does that make sense, guys? User friendly, right? So I was using SQL earlier. Now then I was told that start using Hive. It is, from a user perspective, it is not a big steep learning curve, but from a technology perspective, it's a disruptive technology, right? So basically that's why Hive becomes very popular, right? If I ask people who are doing data analysis using SQL to learn Java, they'll probably run away, right? So guys, whatever little thing which I told you, I mean, it may not be very relevant to this course, but whenever you're trying to build a product, whenever you're trying to architect something, whenever you're trying to build a company, for example, whenever you're trying to do anything like that, just keep this in your mind. A lot of entrepreneurs now have started thinking about marketing their product, but much before that, you have to also understand who's going to use it, how is he going to use it. How is he going to use it is very important, and that's where Hive wins the battle, because Hive actually did not disrupt the usage, right? It disrupted the technology, it disrupted what you could actually achieve without doing a lot things very differently, right? So that's where it was disruptive, and that's why it is so popular, right? So yes, so innovation is very important. I mean, obviously your product should solve a problem, but if it is solving that problem in a very difficult way, and if I, as a user, it becomes very difficult to get those answers. Say for example, if I ask you, Inam, you can get that an answer, but you'll have to learn a lot of Java, then probably you'll not be able to use that product, right? So that's where Hive won. It is similar to SQL, and it uses a language called HiveQL. And for managing and querying structured data, that's where Hive is used. It abstracts the complexity out of Hadoop, right? And we'll see that it becomes so simple to do things using Hive, right? No need to learn Java and Hadoop APIs. You don't have to worry about those. It was developed by Facebook and contributed to community. Facebook analyzes terabytes of data every day using Hive. Now, when we write this sentence, Facebook analyzes several terabytes of data every day using Hive. Remember that analytics report which I showed you, right? So that was a customer-facing report. Facebook also will be doing a lot of analysis internally, right? Which will not be exposed to customers, so it has to do that analysis. It uses Hive for doing that as well, right? Is that okay, guys? Can I move ahead here? Do you have any questions here? Are you guys here, or all of you have slept? Can I get an acknowledgement from everyone if you're following this? Are you liking this session, guys? It's very different than. Okay. Okay, I'm getting a lot of smileys. Thank you very much. So Inam says you rock, sir. Thank you very much, Inam. Okay, great. So great. So guys, see, I'll tell you one thing again and again. Being an old man, I mean, I'm sure a lot of you people who are no need to learn Java is something which I like the most, says Rakesh. Okay, I'm sure Rakesh and Inam are good friends. Okay, but then one thing which I'm stressing again and again, probably to the extent of making you making Chand actually hate me, is that guys, as you grow old, you will realize that understanding where to apply something is more important. That's why I actually I've been through I've learned a lot of languages in my life. I've forgotten a lot of languages in my life. Okay, and for good, I forgot a lot of things. But then and I have done many roles also in my life, right from marketing to hardcore coding. So I can tell you one thing, and a lot of product management, product development as well. I can tell you one thing, that understanding your user behavior is the most important thing. And Hive, I absolutely love Hive for that, because Hive makes my life so easy. And I'm sure a lot of you people who will be actually, I'm sure Ravi will agree with that. His clients will be agreeing with that. Is that, see, the whole idea behind the big data revolution is this, that you can do analysis. It's not about MapReduce. Okay. Even if you hate me for that, it's definitely not about MapReduce. Though in the MapReduce class, I told you that there's something very important things there which you've learned. But then this is the most important thing. Why are we doing all this? Why are we all learning big data? Why are so many companies moving to analyzing big data? Because you can understand user behavior and need, and you can target the right. So businesses are going to immensely get benefited out of it. So all of you who are doing this course today, if you understand this part now, I can assure you, you will get and you will probably remember me for saying this. When some of you people who will be, say, 4 or 5 years experience will not appreciate this now, but I can tell you, when you get into, say, 4 or 5 years down the line, you'll start appreciating this fact, when you'll start looking at such problems which you're facing and you're solving, that the reason why Lakshman and everyone is going to get a great job, okay, in the US as well as in India, is because companies have realized the power of understanding the data and drawing inferences out of it. So I'm sure today whoever is learning big data is going to get into a very, very advantageous position. I keep hearing from some of our older students that there was a guy who's working in PL SQL for last 10 years, he was not able to get anything. He now has got 4 jobs. Can you believe that? His name is Dhiren. He was in one of these classes also. Someone told me from the marketing team that this guy got 4 jobs in India itself, and all of them in big data. So, and he did not know Java, by the way. Okay, so he learned Java with the support team, and he's written a very big testimonial also for these people. So I think, and the reason for that, definitely some credit we should also take, but a bigger credit goes to the fact that companies have started realizing the power of big data and big data analytics, and that's why I'm stressing more and more on the use cases and in this class. When we go to our next classes where we're looking at the project side of things, I'll be showing you some very interesting things there. But then take this class as more of a why class, okay? And okay, so Lakshman says it's your efforts who are making us move on. I think this is a very important thing. Okay, so Rakesh says, as you've played so many roles, you should try to get a role in Rajnikant's movie as well. Now, there were 2 Rajnikants in my class earlier. None of them comes to the class anymore. So I don't see any chance of getting any role in Rajnikant movie. Lakshman, where is your friend Rajnikant? Okay, let's move on. Okay, Hive actually, again, same thing. I've already spoken to you. All these things are already being spoken. You understand this easily now. Hive defines SQL like query language called QL, query language. It has a data warehouse infrastructure. We'll be looking at that in a little bit. It provides tools to enable easy data ETL. Now, to get that data very easily, it has tools, built-in tools. I mean, those commands which you'll be looking at. And it also allows programmers to plug in custom mappers and reducers. Okay, so there is similar to the UDF, there's something called UDAF, which you can use to write some complex code also, right? But then coming back, if you look at Pig is more of a procedural language. I'll probably show you that as well. Sometimes it becomes difficult to do things with Hive when you have to do, say, a procedural kind of analysis where you load something and then you do some filtering, then you do some analysis over it. This is more of a declarative. Everyone understands the difference between procedural and declarative, guys? Otherwise, I'll probably look at it from a different angle. Okay, so procedural basically is when you write, you remember the Pig code which we wrote, right? Load, sequentially we do everything, right? You get that data, then you do some transformation on that data, then you do some more analysis on that data. In between, you can play around with that data. Here it is more declarative. You write a SQL query, say SQL star, select this and put it in this, right? So it's not sequential in that sense, right? All these things, all the constraints are solved in a single problem, and then the data is fetched, right? So when you have to do some sequential processing on data, then probably Pig will become more useful. Does that make sense, guys? Does that make sense? Can I quickly get a yes from everyone? Vijendran, are you there with me? I think Vijendra, are you there? Okay. Vijendra, is it making sense? I have not gotten a response from you for a long time, so just wanted to make sure that is it all making sense to you as well, and you're not getting bored with the class. I'll again explain that, Lakshman. Okay, great. So very important. Procedural code is basically a sequential kind of code. Where, say for example, in C, what do? You write a procedural code, one by one steps will happen. In Pig also, if you see, it's very similar. You write a load, then you do some transformation on it, then you do a store and dump, right? Here in SQL, you don't have that opportunity. That's not procedural, right? It's declarative. You say select star from a table, do this, where you write a join, and then you probably dump it somewhere in the same thing, right? Yes. So Parmesh tells me C++ is procedural, SQL is declarative. So sometimes what may happen is you get some data, do some transformation on it using some external thing, and then uh, put it back or do some analysis. At that point of time, yes. So yes, dependent and independent. Great, Rakesh. Thank you very much. So at that point of time, pig becomes more useful, but most of the times you will not be doing some ad hoc analysis, right? You would have clearly defined this, what I want to do. These are the reports which I want to generate on a daily basis. I may be changing those reports, but not on a daily basis. I may be, say, in a quarter, I say now I'll start taking these insights also, and based on this insight, I'll start analyzing some more things. But on a daily basis, you're just pushing more data onto the same kind of queries, right? So there, Hive makes more sense. Okay. So now Hive, what does Hive do? Tables can be partitioned and bucketed. I've shown you an example of that. I'll come back again on that. Schema, flexibility, and evolution. So there is something called the schema flexibility. We will be looking at that as well. What is that? Easy to plug in custom mapper reducer code, similar to UDF. Okay, you can actually plug in a UDAF here, okay, in Hive as well, if you want to. One more very important thing in Hive, okay, which is not available in other things, is you can actually use Hive. You can configure a JDBC or a ODBC driver and use Hive from a web program as well. Okay, so I'll just go into a little bit detail there, but just to make you understand, in Hive, unlike Pig does not have that. Okay, so in your, say, a Java program, if you have to use SQL, you use a JDBC or a ODBC driver. Similarly, in Hive can also be accessed through that. Okay, so that's also one of the clients, one of the ways to access data through Hive. Okay, Hive tables can be directly defined on HDFS. Now, there's a concept of external tables. It is okay. Is it because of unstructured nature of data that Informatica cannot be used for ETL? That's right, Rakesh. We use a lot of Python there, right? So Hive tables can be defined directly on HDFS. There's a concept of external table in Hive. We will cover that. Just remember the term external table. If anyone knows about it, just keep it with you. I'll be discussing that in a little detail now. So that's something which is a very big feature, okay, which I'll ask you, how do you think it will help? But then I'll cover that in a while. Okay, so that's one more big advantage there. Extensible type format function script. So it's pretty extensible in that sense. Okay, so this is the challenge which Facebook was facing. This was the challenge with the MapReduce, and this is where Hive came in with all these features. We'll be looking at each of these features as we proceed in the class. Okay, any questions here, guys? Good, thank you. Okay, we'll also come back to our use case in healthcare, which we are using as a sample case in this whole course. I'll show you how do we do the same thing in Hive, what we did in Pig. It's a fairly simple thing. I'll not get into the details now. All of us remember this diagram? Okay, which is more strong, Pig or Hive? Okay, now this question is something not from a strength perspective, Inam, but from some of these features which I just showed you, right? Some of these features determine where you should use Hive and where you should use Pig. Okay, well, now Hive was developed a little later and it has a lot more things than Pig. Okay, so but then there are a few things where if the data is slightly unstructured, if you have to write, see, not everything can be expressed very simply in a SQL. Okay, Pig has that procedural code using which you can do a lot of analysis. So if the analysis is a little more difficult to do, probably I'll pick Pig there. If the analysis is standard, and if I have to do a lot of data visualization, data reporting kind of thing, I'll probably use Hive. Does that help? Okay, great. So Ramakant says in Pig schema can be built at runtime, but in Hive it has to be in relation before you process. Not really. Let me come to that also, like schema on write and schema on read, the difference between that. Okay, so Hive also helps you there. Okay, great. Now where to use Hive? We've done a lot of, we've also already looked at a lot of this: data mining, document indexing, log processing, predictive modeling, hypothesis testing. We've looked at everything. Customer facing business intelligence. What is customer facing business intelligence? Can anyone tell me that quickly? I have shown you examples of that already. I've already shown you examples of that. Right. Reports used by end user. Right. So basically, the like Amazon recommendations. Well, yes, in a way, yes. That will be more. See, look at this report, right? The Facebook report which we saw, right? That is completely customer facing business thing, right? Or something which Ravi generates for his clients on a per product basis, right? Or e-commerce would be doing on, say, how many people came to this page, what was the what a web analytics kind of things, right? How many people actually took a trial of this course, how many people actually end up signing for this course, what were their sources? All that analysis is customer facing thing, right? Document indexing is, what is document indexing? Can anyone tell me that? Can anyone tell me what is document indexing? Okay, so yes, I have got a few answers here. Document indexing is basically partitioning that index or file indexing for quick retrieval, right? So that's what document indexing, if you look at it from that perspective, it also uses partitioning, right? So basically you partition your document and then assign indexes to that. There also you can use this, right? You have huge data. Okay, say for example a search web search data, right? And you have to index that data, right? Huge data you have, and you have to maintain that data, right? Digital documentation, saving it in an index, right? So does that help, Shyam? Okay, so that's where Hive is used. Now coming back to our presentation, customer facing business intelligence we've understood. So all these things we've understood where Hive is used, right? Now if you look at the architecture of Hive, this is how it works. On top of Hive query language, there's something called a meta store. I'll be showing you what a meta store is. Meta store is nothing but the place where you actually will be storing the schemas and everything of the tables. Okay. So you have a JDBC, ODBC support here. You can talk through JDBC, ODBC as well to Hive. You can actually use Thrift API to talk to Hive through various other interfaces, various other languages. Okay. Internally, it will have every Hive QL will be converted. It will be parser, planner, and optimizer, which is very similar to what you have in a SQL. Then the execution happens. You can also use user-defined MapReduce scripts here. Okay, can use UDAF here, and then there is a serializer, deserializer, which can convert your data into, say, bytes. What is a serializer and deserializer? Anyone who has any idea about that? So say when you are moving your data from say a parallel to a serial kind of thing, okay, whatever format it is, when you have to move your data across, say a network, or you have to move your data from one point to another, you will probably serialize your data and move it, convert it into bytes and move it. Okay, so that's where a serializer SERDES comes into place. Okay, and when you come back, you will probably deserialize and put it in a format in which you understand. Okay, does that make sense, guys? So this is how basically when you have to move this data from Hive to HDFS, this is how it will work. It is like multiplex, right? But you will make it a serial single bit data, right? So then Hive has a lot of support for a lot of ways in which you can see. It was built for this particular thing where you will be doing analysis and reporting. A person, again, from a usability point of view, I may be using some particular tool to do that, and if I get a Thrift API, then I'll probably read the data from Hive and use my own tool for doing that. Okay, Thrift will, and someone else has to, the other tool has to support a Thrift API as well, right? Makes sense, guys? Does that make sense? It's a very, very important thing to understand here. Can I get a yes? Is everyone clear with this? Any questions on this diagram? Good, thank you. Let's move ahead. So what are the different components of Hive architecture? I will look at Metastore in a while, but shell is one. You can use your Hive shell to actually do a lot of processing, which we'll be using today. Yes, Thrift can be used by no ODBC support products as well, right? So Thrift, Rakesh is asking me a question, is Thrift used by no ODBC support products? Right. So Rakesh, see, Thrift is a, as I told you just now, Thrift is designed in a way that it is an interface definition language where if you have different interfaces which do not know each other, you can use Thrift to make them talk to each other. Okay, so at one end there could be PHP, on other end it could be C++. Okay, and if you want to make them talk to each other, Thrift is the framework for doing that. Okay, so does that make sense? Great. Now, so shell is one, the compiler is another one. Compiler will be actually compiling your query. Okay. Yes, Chand, that's right. So compiler will be used to compile your query, basically look at optimizing the query, and then there is an execution engine which will actually execute it. The driver will be the one which is sitting in between, say, ODBC and your Hive to actually figure out what should go there. Okay. Now coming to this Metastore. Metastore is a small database in Hadoop, in Hive, which is used to store all that related information to the tables, like your schema. All that information is stored in the Metastore. Okay, we'll go into a little bit of detail here about this. So Hive basically has three ways of usage. Basically, you have a driver which will be, this is your actual Hive. Okay, then there is a Metastore in which your table related data will be stored, and then this is where it actually is storing it. Okay, in a Derby database, if you look at so there are three ways of storing it. Embedded Metastore, where a Derby database is used. Okay, there's something called a local Metastore, where if you are so if you have a single user, then this is good enough. Okay, most of the times it will not be like this. It is more of, say, in production mode, this is not how things will be. Mostly it will be this, but let me come to this one by one. Let's look at a local Metastore. Now this outer, this layer signifies the Hive JVM. Okay, now inside Hive you are using the Metastore. Data is being stored in the MySQL. Instead of Derby, you store the metadata in MySQL. There could be multiple instances of Hive. There may be multiple users who may be using Hive and referring to a single database here. Okay, so this is also fine, but then you'll have to share your credentials of MySQL inside this JVM itself. To make it more secure, what we do is you move your Metastore also outside, and that's where you called it a remote Metastore. Embedded Metastore has Metastore and Derby database along with Hive. A local Metastore has Metastore inside this, but the actual MySQL storage is happening remotely. In this case, in a remote Metastore where you want to actually make sure that there's a you don't have to actually pass on the credentials of this place to this to Hive or to a user, you will probably use a remote Metastore where you will have a driver here. The Hive, this is Hive, then this is the Metastore, and my Metastore is talking to MySQL. This is the this is how the architecture will be most of the times of the Metastore, to support multiple users or multiple places without compromising on any security, right? Does that make sense, guys? Is this clear to everyone, or do you have any questions? This is an important thing. I may repeat this as well. Hive can be run in 3 different modes, but usually when you are using it alone for some kind of lower level analysis, you will probably use this enum. If you're in an organization, if you're on a small team, you'll probably use this, something like this. If you're in a larger organization where you want to actually hide the database credentials because no one wants to share the database credentials with the external application, you will be using something like this. Okay. From a security point of view, the remote Metastore makes the most sense because you're not sharing your database credentials. Okay. Is that fine, Naimesh? So here the database credentials are with this Metastore, which is outside of your Hive. Okay. So in remote Metastore, what you've done is you've taken the Metastore JVM also out of the Hive JVM, and the Metastore as well as MySQL are sitting together remotely. This guy is only talking to the Metastore. Okay, is that clear to everyone? Tushar and Naimesh? Most of the times you'll be using MySQL here. Though I don't see any reason why you cannot use something else, but most of the times you'll be using MySQL here. Okay, Shyam? Great. So if this is clear, this is a very important concept to be clear. It is a service JVM. It's a Hive service JVM only, Rakesh. Now this is a very important concept because a lot of times this is one question which may be asked in interviews. Okay, so just to be sure about this, that you don't miss this. Limitations of Hive. Hive is designed for online. Hive is not designed for online transaction processing. It does not offer real-time queries and row level updates. We've already seen that. I've told you this earlier. Latency for Hive queries is generally very high in minutes. Provides acceptable, not optimal latency for interactive data browsing. Okay, now one by one. Latency for Hive queries is generally high, right? That's why it is not used for real-time queries. And we've seen already those reports which you're looking at, the Facebook report was not a real-time report, right? So that's why it is not also not used for online transaction processing. Okay, and then does not offer this. Data browsing can be done, but it is not very fast. Okay, that's not where you'll use Hive. You'll probably get the data and then you will do analysis over it, or you will do browsing over it. You will not be doing an interactive data browsing. So you will not be getting data from HDFS every time when you're doing this. Okay.